this video we are going to discuss another typical concentration term which is called percentage leveling of oleum. So first start that what is mean by oleum. So oleum is homogeneous mixture of H2SO4 and SO3. It is homogeneous mixture of H2SO4 and SO3, and the more precisely, the very important thing that we can represent the oleum like this H2SO4.XSO3, which means that this SO3 present in the oleum has varying composition. So the SO3 which have the varying composition in this is called free SO3. Now this free SO3 will react with water to give H2SO4. One thing more, we can write this H2SO4. Yeah, we can say that the SO3 which is present in this H2SO4 is called combined SO3. It is called combined SO3. So as I told you that the free SO3 which is present in the oleum sample is converted into H2SO4 on reaction with water. So we can study the stoichiometry of this reaction. Obviously the reaction follows 1:1:1 stoichiometry. So 1 mole of free SO3 react with 1 mole of water to give 1 mole of H2SO4. So we can say that for 80 gram of SO3, free SO3, 18 gram of water is required. So this oleum sample, how we can label this oleum sample, or how we can decode if the oleum sample is labeled by if this is oleum sample, this oleum sample is labeled by 109%. So how we can decode this? So if oleum sample is labeled by 109%, it means that 9 gram of water is required for 100 gram of oleum sample, so that entire free SO3 is converted into H2SO4. Yeah, so that no free SO3 is left. So what I said, 109% labeled means 9 gram of water is required for 100 gram of oleum sample, so that no free SO3 is left. So it is converted into H2SO4. Yeah, we can say that maximum 109 gram of H2SO4 is formed. Obviously no free SO3 will be left. So what we have understood that for 109% leveling, mass of water will be 9 gram and mass of free SO3 will be, we know that for 1 mole it is required 1 mole. So for 9 gram, which means half mole of free SO3 is required. So 40 gram free SO3. And how we can calculate the mass and the maximum mass of WH2SO4 means that this is maximum mass, that will be equal to 109 gram where no free SO3 is left. Now how we can calculate the combined form of SO3 which is present in this oleum sample? Very obvious, 98 gram, we can take this equation that 98 gram of H2SO4 for 98 gram of H2SO4, 80 gram of combined SO3, 80 gram of combined SO3. So for x gram of H2SO4, we can write the equation as 80 upon 98 into x. This will be the amount of combined SO3 present in this H2SO4. Now, this 109% labeling, we can say that this sample of oleum will be 100 gram. Now this oleum sample is labeled as 100 plus X percent. 100 plus X percent, which clearly means that 100 gram of this sample, 100 gram of this sample require 100 gram of this sample require X gram of water, so that no free SO3 left, right? So this 100 gram of sample required X gram of water, so that no free SO3 is required. So this is a way of labeling of oleum sample. This X is what? Minimum mass of water. Minimum mass of water required for 100 gram of oleum. This is very important, so focus on this, that X is minimum mass of water required for 100 gram of oleum. From this example in which the oleum sample is labeled by 109%, it is very obvious that the required amount of water WH2O required is 9 gram. So when we will add the 9 gram of water, essentially the entire free SO3 present in this sample will be converted into H2SO4. But when we are not providing the sufficient amount of water, suppose we are providing, if we are adding 6 gram of water, what is mean by this? We required water is 9 gram and we are adding 6 gram of water. So obviously the added water is not as much as sufficient as the required. So some of the free SO3 will be left. Some of the free SO3 will be left. And definitely this oleum sample required new labeling. This oleum sample required new labeling. But if sufficient water is provided, added water is as much as sufficient as required, then the entire free SO3 will be converted into H2SO4. Now what will happen if we are providing excess of water? Suppose if we are providing, if we are adding, suppose 20 gram of water. So the added water is more than required water. So definitely after converting the free SO3, because to converting entire free SO3 9 gram of water is required and we are adding 20 gram of water. So after adding 20 gram of water, 9 gram water will be used to convert SO3 completely into H2SO4, and definitely 11 gram of water will be left. So the final sample contains H2SO4 plus water. And to be noted that H2SO4 and water is not, we can say, oleum, because oleum is the homogeneous mixture of SO3 and H2SO4. So what I said, if an oleum sample is labeled by 109%, it means that mass of water present will be 9 gram, and WSO3, which is the free SO3, will be present 40 gram, and we can say that maximum amount of H2SO4 which can be produced will be 109 gram, and the mass of oleum sample will be 100 gram. And the second thing, what I told you, if oleum, we can label the oleum sample as 100 plus X%, which clearly means that 100 gram of this required X gram of water, so that the entire free SO3 is converted into H2SO4, or we can say that no free SO3 will be left, right? So, and in the third case, in the third point, I told you that if we are adding the water as required as the labeled sample, which is, for example, 109%, 9 gram of water is required, and we are adding the 9 gram water, so it will be converted into completely into H2SO4, no free SO3 is present. But if you are adding less amount of water, definitely some free SO3 will be present, and it is required to label sample again. This will be the new sample. And if we are adding excess water as required, suppose 9 gram and 20 gram, then excess of water will be present, extra water will be present in the sample, so final sample contains H2SO4 and H2O, so this is not oleum sample. We can take one thing more, that oleum sample reacts with base also. So reaction with base, this is oleum sample, which is homogeneous mixture of SO3 and H2SO4. When it reacts with NaOH or any base, we can write the reaction for this: SO3 plus twice of NaOH, this will give Na2SO4 plus Pani, which is H2O, and in the same way H2SO4 plus 2 NaOH, this will give Na2SO4 plus 2H2O. So these are the reaction of oleum with the base. Obviously from the first equation it is following the 1:2 stoichiometry, and in the second reaction it is following the 1:2 stoichiometry. So from the first reaction, moles of NaOH required to neutralize the SO3 present in the oleum sample will be twice of moles of SO3, and from the second reaction also moles of NaOH required will be twice of moles of H2SO4. So these are the reaction of oleum with base. Now we can take one more point, that what is the range of labeling of oleum. So maximum and minimum range of oleum. So to be noted that minimum range of oleum will be 100, and the maximum range will be 122.5. So we can say that the range of oleum, we can say that range of labeling of oleum will be as I told you that the maximum is 122.5 and minimum is 100. So we can label the oleum sample as 100 less than 100 plus X%, which will be greater than 122.5. 122.5 is the maximum and 100 is the minimum. So the labeling of oleum sample will lie between these two range. How we can decide the maximum range of this oleum sample? As we know that SO3 on reaction with H2SO4, H2O converted into H2SO4, this is free SO3. So we can calculate the mass of water required to convert the entire free SO3. So we can say that for 80 gram of SO3, 18 gram of water is required. So for 1 gram of SO3, it will be 80 by 80, 18 by 80, and we can calculate for 100 gram, 18 by 80 into 100, this will give 22.5, and we know that this is the amount of water. So we can add in 100 plus 22.5, this which will give the maximum range of oleum. So in this video we discuss the important concept about the oleum sample and what is oleum. In the next video we will solve problem based on oleum sample.